This is one of these paid class series, and we'll try to go through questions. NECO BECE exam, and they will be solving questions from 2021, NECO BECE 2021. I'll be doing some other videos much later. I've done a lot of videos on this, but this one is a paid edition. So because I record my classes, you have the opportunity of reviewing certain sensitive aspects of the classes, and then you'll be able to go back much later to work. All right, so we'll go over the questions. I'm actually reviewing the students' work, and we'll be solving paper one. Paper one of NECO BECE. So maybe I should write that on the board. It's mathematics. So it will be NECO BECE 2021 mathematics. And we'll be looking at paper one. Paper one. I always tell students that for exams like this, the most important thing you must remember is your speed. You really need to be fast. Really need to be very fast so you can finish on time. Now I said, what is the place value of 7 in this number? Now, number one, paper one essentially talks about arithmetic and geometry. Paper one is essentially what? Arithmetic and geometry. Arithmetic and what? Geometry. So the arithmetic will be anything in arithmetic other than statistics and probability. In the Mambo experience, probability and statistics are classed as arithmetic. But in the BECE experience, statistics and probability is kept aside, forms part of paper 2. And this aspect we're treating now is about 24 questions. You get about, say, about 24 questions from this, and then you have about 36 questions from geometry. All right, so let's go ahead. Paper one says, question one says, I have a number. I have the number 2, 3, 7, 6, 4, 0, 0. So that is 2,376,400. Now we're told to discover the place value of 7. Now look at 7. It says, what is the place value of 7 in this number? Look at the position of 7. That position of 7. Now this is units, this is 10, this is 100, this is 1,000. Now, technically speaking, all the numbers here are all 1,000. So we repeat cyclic, units, tens, 100. So this is units 1,000, 10,000, 100,000. So this will be 10,000. So that will be what? 70,000. All right. That's for question number 1. Now for question number 2, it says round off 0.004365 to what? 2 significant figures. We want to round off this number to 2 significant figures. Now, there are 2 aspects of significant figures. There are the numbers that are whole numbers, essentially whole numbers with decimal parts or just whole numbers. There are what I call pure decimals, may not be a conventional word used in maths. It's what I call pure decimals. A pure decimal is any number whose highest digits does not exceed tenths. This is tenths, this is hundreds, tenths, 100,000. So if I have a number as this, the most significant digit will be the first non-zero digits. If I have a number like this, the most significant digits or the first significant digit will be the number, the first non-zero digit. So this is the first digit, this is second, third, and fourth. So we're told to approximate to 2 significant figures. So what that means is that this will be the first, this will be the second. So two significant figures will mean use these two. So the digits, this digit is what I call the digit of interest, because I'm told to use two significants, digit of interest, and this is the digit costing the approximation. If this digit is 5 and above, we'll add 1 to this. If this digit is lower than 5, we will add 0 to this. So, or some writers will say it remains the way it is. So this answer becomes 0.0044 to what? Two significant figures. So that solves that one. Now, if you, by way of answer, this would have been D, and this would have been D also, right? Interesting one. So we go to question number 3. In question number 3, we are told to find the square root. Find the square root of what? 144 over 256. Here, you need to be conversant with the knowledge of your square, your perfect squares. Perfect squares. What's a perfect square? The concept of perfect square is that I think of a number such that when I multiply two other numbers that are the same, I get that number. For instance, 1 is a perfect square because 1 times 1 will give me 1. 4 is a perfect square because 2 times 2 will give me 4. 9 is a perfect square because 3 times 3 will give me what? 9. So that's the concept of perfect square. So in this setup, if you've been practicing very well, you know that 144 is a perfect square, and it will need me to do what? 12. So if I multiply 12 twice, I'm going to get 144. Now, 256, if I multiply 16 twice, I'm going to get what? 256. So this is what I'm going to have, and final answer becomes 3 over 4. Now that's one method. Another method would be I try to reduce this one first. What can divide top and bottom will be what? 4. 4 can go into this, I will have what? 36. 4 can go into this, I'm going to have that will be 64. 4 can go into this, I'm going to have 9. 4 can go into this, I'm going to have 16. So what's the square root of 9 over 16? That will be 3 over 4. So whichever method you use, you're going to arrive at the same answer. Okay? All right, so that's for question number 3. And then we'll go to question number 4. And for that one, the answer is available there, and that will be C. Now for question number 4, it says express this number 2,734,000 as what? In what? Standard form. How do you do that? Quite simple once again. What you simply will do will be to say, what is standard form? Standard form is the expression of a number, a decimal fraction, as a unit decimal. Big grammar. Let's see what that one means. It means I look at this number, I try to write this number as a unit decimal. A unit decimal is any number that has the unit as the highest significant digit. So if I'm going to write it, this will simply be what? 2.734 times, what movements have I made to get this? This is a whole number. So for every whole number, the last digit is significant. So I move back 1, 2, 3, 4, 5, 6. So I've made 10 and 6 steps. I've made what? 6 relevant steps to get this. So in converting this to standard form, it will be 2.734 times 10 raised to the power of what? 6. And that gives us our answer. So that answer will be D, if I've done the correct thing. Now remember that my objective in solving this problem is not to show you how well I can solve, but to give you an idea of what you should be thinking in your mind when you solve this problem. It's possible that in the course of solving we may have made some errors, and I tell my students, the ability for you to be able to spot those errors means that understanding is taking place. Whenever a student is able to spot an error, it means you're understanding, and that's a good way to start. All right, so we go to question number 5. In question number 5, we have 4, 1/6 minus 2 whole number, 5/8. Now, this is also another very simple question to solve. This question is testing your knowledge of fractions, addition and subtraction of fractions. And in this problem, we are subtracting fractions. We're doing what? Subtracting fractions. I've seen a lot of teachers do this. They turn this to improper fraction and then you solve. Oh, fine. In an exam setup, oh, fine. But technically, whenever you are adding or subtracting fractions, we expect that you do that in what I call the, what's that one called now? Mixed mode. I call it the mixed mode, something I developed, mixed mode. There's mixed mode. Mixed mode is a mode where I don't turn this to improper fraction because I'm adding or subtracting. So when I'm adding or subtracting fractions, I keep it in a mixed mode. So what I do is I treat whole numbers, 4 minus 2. Then I treat the fractions by looking for their LCD. Now the LCD of 6 and 8 is 24. Somebody would ask, how are you able to just get that quickly? I'll give you a little trick. Now look at 6, look at 8. 6 is essentially what? 2 times 3. 8 is essentially what? 2 times 2 times 2. Now the rule of this game says pick every prime once. So if you look at this now, or rather pick the primes. For LCM, you pick all the primes of a particular number and then go to the next. Now I'm seeing 2. If I pick these 2, I will pick these 2. So that is 1, 2, 3. So that is 2 times 2 times 2, and that is what? 8. Now, I pick this last 3. So that will be 2 times 2 times 2 times 3. So that will be 2 times, I picked 2 2's from here, and then times 3. And that will be what? 24. So that's how I got my LCD to be 24. I have other classes where I will spend more time to do this, but just to help you understand how I quickly get these answers. All right, so 24 divided by 6 will give me 4. 4 times 1, that'll be 4. The method is this divided by this times this. This divided by this times this. So 24 divided by 8 will give me what? 3 times 5, that will give me what? 15. So I'm going to have 2 whole number, 4 minus 15 over 24. It's not possible. It's not possible. So what do? You take 1 from here. And every 1 you take is equal to 24 parts of 1 over 24. So this will be what? I take 1 from here. I'll be left with 1. And then I bring in that 24 here. What am I doing? I'm going to add 24 to this 4. So that I'm able to remove what? 15. I can't remove 15 from 4. Because the rule, if you're coming from primary school onto GSS, you're not being taught integers. So the understanding there is that everything you're dealing with must be all positive. So how do you do that? This 24 tells me how many pieces are available in 1. Now 1 in this atom is equal to 24 over 24. 24 pieces of 1 over 24. 24 pieces of 1 over 24 is what? 1. If you have 6, for instance, 1, you want to break it to 6 parts, you cut it 1 over 6, 1 over 6, those 6 parts. That's the same thing as what? 1. If you had half in 2 parts, that will give you 1. So that's the understanding we're using here. When you just turn to a proper fraction and you solve and run away, this idea is lost. And more often than not, when you come to certain sensitive areas of math, you will struggle. So sometimes we should try as much as possible not to take shortcuts. Sometimes it causes a lot of problem. Let's learn the things as they ought to be, so that when we get to those areas of math, we'll be able to survive. So this will give me one whole number, 28 minus 15, all over 24. So what is 28 minus 15? That will give me what, 13, if I've done my maths right. And that will be one whole number, 13 over 24. Now, the big question here is this. If I use the other method, am I correct? Oh, you're very correct. You're very, very correct, especially in an exam setting. Nobody will penalize you for that. But you would have lost a very valuable idea that you can use to solve other problems. What I do in the Mambo experience is to stretch your thinking, to open you to different variants, nexus characters, and possibilities, time, outcomes. I open you to a lot of outcomes. So you're not going to the examination hall as a robot. You're going to the hall with a mindset that you can use different possible ways to solve the problem. All right. Now, this answer will be C. All right. So we're done with that, and I'm going to clean off. Okay, so go to question number 6. And in question number 6, we are told to express 112 as a product of its prime factors. As a product of its what? Prime factors. Now, there are different methods you can use to solve this. I'm going to use a few methods to solve this. There are about 2 or 3 methods you can use to solve this, but let's just start. Now, the simplest method students remember will be this. Now, take note that I'm taking out time to solve the problems, to give you different possible ways to solve them. This will give me 56, 2 into 11, 5, carry of 1, 28, what's here, 14, 7. I can see a lot of students nodding their head. Yes, I know this method, fine. And this will be what? This would have given you 2, how many times? 1, 2, 3, 4. 2 to the power of 4 times what? 7. Yes, that's very, very correct. But there's also a faster way to solve this. Now, we can use our knowledge of factor tree. What do you call it now? Factor tree, yes, to solve it. And we can also use our understanding of rules of divisibility to solve this. From my rules of divisibility, if a number, the last 2 digits of a number is divisible by 4, that number is divisible by 4. So I know that this will be what? 4 times what? 28. So I already know that I'm going to get 2 twice here. And I know 28 is what? 4 times what? 7. So I'm going to have 4 times 4 times what? 7. So from here, I can just simply say that I have 2 occurring how many times? 2 here. I have 2 occurring 2 times here. That will be 4 times it all times 7. And that's what the answer will be as product of prime factors. You may want to look up my videos on, I think that should be grade 7 arithmetic. You go to my YouTube channel on Mambo with Jarvis, look for grade 7, go to my playlist, look for grade 7 and search for arithmetic factors. I've done a very serious work on this LCM, prime factors and things. You really want to watch that video because I took out time to break ideas on how you can get this thing. Some of these methods are becoming archaic, they're becoming obsolete. You can actually look at numbers. Whatever you do when you solve problems, try as much as possible to stretch the scope of what mathematics is offering you. Don't tie yourself that this is how you must solve all the time because examiners are also getting smarter. They have a way of twisting the questions. They are more IQ driven today. They set questions and some of the questions you can actually just look at them and tell the answer. All right, so that's for question 6. And I'll go to question 7. It says express 0.3125 as a percentage. Now, to obtain a percentage, you multiply by 100. To obtain a percentage, you multiply the given decimal by what? 100. And when you multiply by 100, what happens? Multiplying by 100 moves the decimal places to your right. So if I'm multiplying by 100, it will move the decimal places 2 steps to the right. If I multiply by 10, 1 step. If I multiply by 1,000, 3 steps. 10,000, 4 steps. So the movement is intense, right? So this will give me what? 31.25. And that answer percent, and that answer will be what? C. So multiplying by a percentage, which is 100, will be move the decimal place to what? Move the decimal place 2 steps. And if we're right on this answer would have been 8. So I didn't put that. And then we'll go to question number 8. Question number 8 is testing your knowledge of addition of numbers as what? Decimals. Now we can do addition in decimals. So we have 3.13. It says find the sum. Every time you hear the word in maths, sum, it means addition. It means what? Addition. So anytime you hear sum, please know that they want you to do what? Add. And this will be 4.171. Please, you notice that this is 3.13. So when you're writing, also align them in that order. And as I always advise my students, put a 0. Once you write the next one, I discover that it stretches out. Put a 0 on top so you don't forget. All right, the next one becomes 1.1. So put a 0. And then you have 2.02. Put a 0. And then you have 6.069. So we're going to add them. We're going to do what? Add them. So how do you do that? 1 plus 9 will give me 10. Is that not? So I put a 0 down and have a carry of 1. Now, there is no given rule for how you add. I know 3 plus 7 will give me 10. So 10 plus 1 will give me 11. I just write it somewhere so I don't forget. I look at this. 2 plus 2 is 4. 4 plus 6 is what? 10. 2 plus 2 is 4. 4 plus 6 is 10. I add that 10, then that will give me 21. So I put down what there? I put down 1 and I have a carry of what? 2. Now I come here. This is 1, 2, 3 plus this 2. That will give me what? 5. I come to this last part. 3 plus 4 will give me 7. 7 plus 1 will give me 8. 8 plus 2 will give me 10. Once I get to 10, I note it down. And then 10 plus 6, that will give me 16. So that will be 16.510. If I've done that correctly, that's what my answer would be, 16.510. After the decimal point, we read each digit as a single number. So that's 16.510. All right, so that's it. The option available for me there is 16.51. And that option will be E. So that's for question number 8. Question number 8. So we'll go to question number 9. And in question number 9, it says find the value, or rather find the value of 2 raised to the power of 2 times 5 minus the square root of 16 plus 8 divided by 4. This is one question where your board maths or bid maths is being tested. Board maths or what? Bid maths is being tested. So how do you handle a problem like this? You have to be very, very careful. In this setup, do the division first. There's no bracket, so do the division first. So I will treat these 2 first. I'm going to take it stepwise so that you see what's happening. I'll do these 2 first. I'm going to have 2 raised to the power of 2 times 5 minus the square root of 16 plus 2. Now, 8 divided by 4 will give me what? 2. So what you have here technically is something like this. Are we seeing it? That's what you have. So the next thing you do 2 raised to the power of 2 is what? 4. It will affect the problem. So you can do that. That'll be 4 times 5. Some books will say that 1 is what? That 2 raised to the power of 2 is what? The index, big maths, basic big maths index. So minus the square root of 16 will be 4. It won't affect your problem, what you're doing. It won't affect it. Plus what? 2. Now, this is where you now need to be very careful. You need to take care of this first. And that will give me 20 minus 4 plus 2. Now, it says do addition before you do subtraction. But I'm going to tell you that you can do both together. The most important thing is for you to be very careful about what you want to do. What is the value of 4? 4 is negative here. This is positive, this is positive. So I will add up 20 plus 2. Or I can say 20 minus 4. That will give me 16 plus 2. That will give me what? 18. If I say 20 plus 2 and I remove 4 from it, I will still arrive at the same answer. As we get to some of these problems, you discover that it doesn't really matter which one you do first. What you need to take note of is their values. If it is negative, it means you have to subtract. If it is positive, it means you need to add. All right, so the final answer becomes 18. And if we have done that right, that option will be C. And that takes care of that problem. All right, so we go to question number 10. And this is the first question that talks about what problem. A man spends 2/7 of his income on clothes and half of the remainder, careful with those words, half of the remainder on food. What fraction of his income is left? Now, this question is testing your knowledge of fractions. And hear this as a golden rule. For every question involving fraction like this, the whole process is 1. It says a man spends 2/7 of his income. His income in this setup is 1. 1, whole number 1. Everything you're going to walk around will be what? 1. He spends 2/7 of his income on clothes. So, fraction for clothes. 1 minus 2/7. We said that the whole process is 1. What would that be? This 7 can now be what? This one can now be 7/7 minus 2/7. By our concept of like fraction, this becomes 5/7. The concept of like fraction says that if the denominators are the same, what happens? You subtract the numerators. So that takes care of that. So that's that. Now, okay, sorry. So I think I mixed up the idea here. So we'll just go back a little. Sorry about that. Fraction on clothes will be 2/7. So fraction remaining, of course, it's remaining after clothes have been taken care of, will be 1 minus 2/7. And that will be what? 7/7 minus 2/7. And that will give me what? 5/7. Now, it says, and half of the remainder of food. So fraction of food will now be equal to 5/7 times 1/2. It says half of the remainder of food. So that's what that will mean. That will be what? 5/14. It says what fraction of his income is left. So the first thing you need to do is to take care of fraction spent. And that will be add this to this. So that will be 5/14 plus 2/7. Now, I can actually convert this to a similar fraction or a fraction that will have the same denominator. So this will be 5 over 14 plus multiply numerator and denominator by 2. And that becomes 4 over 14. This is the beautiful thing about maths. If you watch what I do, we explore different ideas. Use the ideas. Use them. Play with them. And that will give me what? Like fractions. I'm using my concept of like fractions now. This will be 9 over 14. All right, so fraction left. What fraction will be left? That will simply be what? 1 minus 9 over 14. So that will be what? 14 over 14 minus 9 over 14. And that will give me what? 5 over 14. So what is left will be what? 5 over 14. If I've done that, if I've done this work correctly, I should be having that as my answer. That's 5 over 14. I've done that correctly. So we'll just check. And if in the course of solving you get a different answer, just ensure that you follow the procedure, and that should be it. 5 over 14. 2 over 7 plus 5 over 14. All right, so that takes care of that. And then we'll go to, so that option is C. Then we go to question 11. It said increase 5,400 meters by 12%. By what? 12% increase. To increase is to go above the original. To decrease is to go below the original. So if this were to be the original, my final answer will be higher than this. Now, the different methods students can use. The student can say, okay, this one method students usually use, say 12 over 100 times 5,400 over 1. Then I multiply these two. Multiply this by, the way I go, I multiply by 2 first, I'll get a 108. And then I multiply by 6 left. You can do that. It's not much of an issue. That will give me 648, right? And then that's 648. I will add it to this. Now that's where a lot of students may miss it out. So increase is to make this bigger. So the answer you must get must be higher than this. If you get an answer less than this, something is wrong. So if I add that, that will give me 6,048. So that answer becomes what? E. But there is a method I want students to get used to. Increase by 12% means that the original was 100%. Plus the increase I have made, that will be 112%. So I will say 5,400 times 112 over 100. Straight away, I will then cancel this. Cancel this. And then I will multiply this. And if I multiply this, I'm going to get this as my final answer. So there are, in an OBJ exam, this method seems to be a faster one because you wouldn't play with so much numbers. But remember too that there is also another way you can go about solving this and arriving at the same answer. All right, so we look at question number 12. In question number 12, it says convert 1011 011. Now students will say it's 100 and no. For a denary, denary means base 2. So denary means base 2. So I will write base 2. Oh, sorry, binary. Sorry about that. Binary means what? Binary means what? Base 2. Denary means base 10. So they say convert to denary, it will mean convert it to base 10. Convert to base 10. So the first thing you want to do is to attach what I call values there. 0, 1, 2, 3, 4, 5, and 6. I think we should write that out so that you can see what I'm doing very well. 0, 1, 2, 3, 4, 5, 6. So this will be 1 times 2 raised to the power of 6 plus, I don't need to consider these ones because it's 0. Anything 0 multiplies will give me what? 0. So I go to the next one, 1 times 2 raised to the power of 4 plus 1 times 2 raised to the power of 3 plus 1 times 2 raised to the power of 1. But I'm not using these two. Plus 1 times 2 raised to the power of 0. So this will give me 64. This will give me 16, if I'm right. 8, 2, 1. Because 2 raised to the power of 0 will give me what? 1. So with that done, this two will give me what? 80, 90, 91. So my answer will be what? 91. And that answer will be what? E. All right, that's for question 12. So for question 13, express 0.000743 times 10 raised to the power of 2 in standard form. Here you need to be very, very careful. Here you need to be very, very careful. Remember we said that 10 raised to the power of 2 is 100, meaning that I must account for the 2 decimal places first before I do anything. So this 10 raised to the power of 2, we move these decimal places 1, 2. So first of all, going to have 0.0743. Is that after I've gotten this, I can now begin to talk of what? Expressing in standard form. I must take care of this before I proceed to do this. So this will now be, how many decimal places now? 7.4243 rather. Unit decimal. We said that standard form is expressing a decimal fraction as a unit decimal, right? So times, how many movements have I made to make this possible? 1, 2. And that'll be 10 raised to the power of -2. Why -2? Whenever you try to make a number that was small to become big, it means you're forcing what ought to be, what ought not to be. So that is negative. If you have a big number, you want to make it small. To take it back, you need something big now. But this one is small. You want to force it to become big. What will happen? It's negative. It's not possible. All right, so that will be my final answer. And that answer will be what? C. So we'll go to question number 14. In question number 14, it says, which of the following number or numbers is the greatest? This one I'm going to write on the board so you can have a perspective to that. I have 1.4 times 10 raised to the power of 5. I have 3.0 times 10 raised to the power of 4. I have 2.3 times 10 raised to the power of 3. I have 4.3 times 10 raised to the power of 2. I have 9.7 times 10 raised to the power of 1. Now, which of these numbers now, he said, is the greatest? In solving this question, what you need to look at now is all of these parts are all unit decimals. So our comparison is not here because everything here, they are all in unit decimal form. Our comparison will now be here. We look for the one that has the highest power here, and that is what? This one. So the answer simply will be what? 1.4 times 10 raised to the power of 5. So this one is a very straightforward question. It's just, this is one of those questions we call IQ questions. It's testing your ability to understand the concepts. So all of these are all unit decimals, so I can't use this as a basis for comparison. I will come here and check. I see a steady decrease in the powers. So this obviously will be the one with the greatest. Obviously be the one with the greatest power there. Is that okay? All right, so that answer will be A. So our final question for the morning, will be the square root of 444x squared divided by 4. please, when you're solving questions like this, be careful to see where this square root sign is covering. The square root sign is only covering the numbers or the terms on the. So the square root sign, like I said, is only affecting the numerator. It's not affecting the denominator. So in this setup, what is the square root of 144? It is what? 12. Concept of square, perfect squares now. What's the square root of x squared? X squared means x twice. And if you remember your grade 7, the square root, concept of square root means pair and pick one. So this will be x divided by 4. And that will be what? 3x as a final answer. So that will mean that answer will be what? B. All right, thank you for spending time with us this morning as we looked at, we've been able to look at our NECO BECE experience for 2021. And we've looked at question 1 to about 15 of paper 1. We will continue on this work at some other time, but I'm trusting that you sit back, watch this video, and I'm trusting it to add more value to your learning experience. Mamu Jarvis will return.